So, okay, guys, you are welcome to the sixth day of our physics preparation for JAM and WAEC 2022. I'm Engineer Oyedi, and once again, now into the topic of thermal properties of matter. And I think this is one of the simplest topic, which you don't have much calculations as the other topics. So now we quickly look into the 16 questions, and please do endeavor to tell a friend about this, as you know that she is doing this, and you can also try and share our content with others. Let's also begin with the first question of today. Now, about the first question we have before us, I think it should be done in 20-25 minutes. I believe we have a liquid rises in a capillary tube, that is capillary action, rather than form liquid in a narrow tube, higher than water. That means that one in a particular liquid is higher than one in water. The difference may be due to the fact that dash. I know you might have talked about meniscus and all those things, but the height of the capillary tube, and they have videos on hydrostatics and hydrodynamics. You can check each of them for comprehensive details, but these are simple things. Height of a capillary tube is given as 2T all over ROG. You are seeing this for the first time, you can keep it that way. So that is the height of the capillary action is directly proportional to twice of the surface tension. Now, in this design, as the height increases, the surface tension increases. So this is the interpretation of this tree. So if liquid rises in the capillary tube than that of water, what it means, because answers are the diameter of the capillary may be different in two cases, not well stated. Temperature does not have effect. You can see that surface tension is less than that is why the one of the liquid is greater than that of water, because they are in the height. So the height of the liquid will be greater because the surface tension of the liquid is greater, and that of the water is less because surface tension of water is also less. So choice C is very correct to that question. Like I said, this is just simple thing about property of matter, and it's just the first phase, but we are still on the second phase. But we have some difficult question, not study, but technical question, and you need to understand. The second one is about surface tension too. Surface tension of the liquid is due to dash. Now, surface tension, we say, is the tangential force or the intermolecular forces that act at the surface of a material that make it look like a stretched elastic membrane. That is the basic definition. It is just a kind of force that acts in all direction, and that it's a kind of similar force between molecules that make them stretch. So you can watch videos on that. When you draw an hypothetical line on the surface of a liquid, you're going to see the force that is dragging them and making them act like a stretch membrane. So surface tension is due to the same force acting between molecules. So when we say the same force, we're talking about cohesive force between molecules. So surface tension is due to cohesive force. You know, we have two types of forces. With respect to intermolecular forces, you can actually say adhesion, force of adhesion, and force of cohesion. That is what also teaches you about concave and convex, the meniscus in last year. I've done that. You can check it out at your leisure. And this is a very simple question. We'll move to the next one. About this, guys, we have why the dam of water reservoir is thick at the bottom? That is, why is the dam water reservoir thick at the bottom? Now, we've talked about this also. I think this on pressure of liquids is also part of the topic. They cross into one another. So the pressure is a dependent of height. We have discussed that this pressure increases with height. So far we have discussed that pressure increases with height, and this pressure depends on height. So you definitely know that there will be some kind of forces acting at the sidewall. So keep it in mind. We've written that, I think, yesterday in day 5. We have our H rho G, the full formula, height density and gravity, because there will be some particular force acting at the sidewall, and because of that, acting at the layer of the bottom, so as you go up, the pressure increases. So that is why it is always thick at the bottom. And so for water, they actually try to prefer low cut opening of water. But for now, I think you guys know pressure is dependent on height. And that is just the reason why you can talk about the dam reservoir is always thick at the bottom. So in fact, you can even go with the options. You can see quantity of water, density of water increases with depth, pressure of water increases with depth, speed of water pressure increases with height is also known as depth. So guys, apologies if I rush a little bit, it's because the forces of thermal property of matter, I believe, is what you all can do. And again, we move to the next question. We have A and B are two wires. The radius of A is twice of B. They are stretched by the same load. Then the stress on B is dash. Yes, we can just go by the formula of this stress because the question is asking with respect to stress. So we've talked about that under the topic of elasticity. And stress is equals to force over area. So there are different types of stress, like I told you there. So in this case, we want to relate stress with the area. So in the way of the physicist, we say stress or mathematics is inversely proportional to area. So it's a wire. And when we talk about the wire, we are talking about wire with radius. So we consider the area in terms of pi r squared. So I can just say here from here, look at the way we do stuff in physics and chemistry. And as well in mathematics, the same methodology is always used. So here you can say the stress of the wire is equal to the constant, and this is the force, which is the load is constant because it is the same load over the area is now pi r squared. For simplification, I can say the stress is inversely proportional to the square of the area. So what I'm saying, guys, is that stress is inversely proportional to what the square of the radius. As pi, I will take as constant now. But pi is also a constant, which is 3.14. Blah, 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 blah. So my point is, if I go with this one, I can say this is stress 1. Look at this. Radius 1 squared must be equal to stress 2, radius 2 squared. As you can see, stress is equal to inverse proportional to square area. So the stress on B, I'm going by stress 2 over stress 1. Stress 2 over stress 1 is equal to, as you can see, you don't need to waste your time. We have stress 1, radius 1. So this will be radius 1 squared over what? Over radius 2 squared. So by what I'm saying, it's so easy to actually finalize my answer now. So we are looking stress on the second wire to that. The radius of A is what? Radius of A is twice that of B. So this is stress 2, which is B, and it's stress 2 over 1 is radius of the first one. Let's take it, it's twice. Let me take the first one to be 1. So the second one is twice of the first one. So that is just what we have. Sorry, the radius of A is twice that of B. As you can see, that's 2 square over that is 4 over 1. So 4 ratio 1, which is going to give you 4. So my point is a very simple question. As you can see, this is twice and this is proportional to the square of it. Your square 2, you are going to have 4 times that of 8. So that is that about that. The answer to that is 6. And I think it's just a simple calculation you can see under this topic. So the next one is a drop of oil is placed on the surface of water. Which of the following statements is correct? Oil will spill over water. We might have done that one because of surface tension. And another thing is what oil is having what less surface tension compared to that of water. So it will spill over water, and that's just because you spread a thin layer over water because the surface tension of oil is less than that of water. That is a very important thing, and always keep at the back of your mind. Still on the topic of thermal property of matter, it will remain on it as a sphere. It will spread as a thin layer that is just surface tension. It will partially it will float as a distorted drop on the water. No, this is surface tension. So I think we are just talking more about surface tension and capillarity concepts this morning. So I think this shouldn't be a problem for us at all. The next question. About this question, we are which of the following material is most elastic? Very good. I think I've done it in my concept video as a technical student, but I want to talk about more elastic material. We measure that using what we call the modulo of elasticity. Modulo of elasticity. So, and when you talk about modulus of elasticity, if you want to write in singular, elasticity, that is also good. Now, we have different modulus of elasticity. That is, we have Young modulus, and we define elasticity modulo in terms of solid materials. We have, in terms of liquid and gases, we define using what we call the bulk modulus. Now, my point is, when you talk about how elastic, the measurement of how elastic a material is, we talk about the modulo of elasticity. And you know that stress is directly proportional to strain. When the stress is applied to a wire, it's going to strain it. Okay? So which we call the extension between the wire. And I'm sorry guys, I think my voice is back now, so you can actually enjoy the voice, even though the voice is too thick. So but by the way, always keep it in mind that what the material that has what that is more elastic or the most elastic material will always be the one that is what the hardest. For example, like I said, stress, most of the students have a misconception. You can watch my video on elasticity. This was well treated. Rubber is not. Because we say stress of the wire is proportional to strain. Thereby the constant is now the what? So we say stress concepts are available, but this is also very simple. It's proportional to strain. So when we introduce what? A constant, then you say what? The constant is now equals to modulus, which will be divided by E if it is, if you know it, if it is Young modulus, most of you are used to what you call a Y, like a Y. So this is an elasticity modulus, which now stress over strain, which is what you might have studied in your junior classes. So what I'm saying is that you can see a constant stress is always proportional to strain, no matter the situation. In fact, when you draw the graph, you have different points, elastic limit, the maximum breaking point, the midpoint, the compressibility point, and so on and so forth. I'm not going to teach myself, but because this particular type of video allows us to do that, well, there's no, you say we don't have calculations like that under this topic for your level, and just really like that for your level. So we only focus on a little bit of talking about the concept a little bit. So what I'm saying is that was material that we have the highest modular of elasticity is what is out of all this one should be what is steel. So please always keep that at the back of your mind. That is iron is more elastic than rubber because stress is proportional to strain. Amount of force that you are going to give into what you can say E is equals to stress over strain. So always keep that at the back of your mind. At every point in time, the stress is always proportional to strain. Like I said, if you have visual concepts wise, watch the video. They are well explained, and this is just a very technical question where most of you are going to fail and thinking rubber is more elastic than what steel. So keep that in the back of your mind. Modulo of elasticity, stress always proportional to strain. Now the next one, excuse me. According to Hooke's law of elasticity is only down property of matter as well. Why? You can just say the way the question has been said with respect to the UTM and Y. If stress is in place, then the ratio of stress to strain is such. You can see ratio of stress to strain, just like what I did now, is modulo of elasticity. It's always constant. So when stress, so that question that is technical, is always proportional to strain. That's what I talked about right now. So stress is now equals to E strain, whereby E is modulo of elasticity. And if you make E subject of formula, you know E is a constant, where E is constant. Already discussed. So E is constant and it is called modulo of elasticity. I told you for solid it is called Young modulus, for liquid and gases it is called bulk modulus. So that concept of Stanley, you might have talked about that. In fact, I think it's also part of what UTM is asking in the same time. So this is a constant, which we call Young modulus. And I told you E is not equal to stress over strain. This is the definition we give to Young modulus. So the ratio of stress to strain is called modulus. Are you getting it now? Excuse me. So the ratio of stress to strain is constant because it's a constant when stress is proportional to strain. So be careful about picking options. I do tell my students in offline classes, you just have to know concept. Because that is what most of you might have think the answer is in grades because you only believe this is just the relationship you know. That is, this is E equals to stress over strain. So E is proportional to stress. So when stress is strain will increase. That is what not knowing concepts in details. So you just need to be careful so that you don't make mistakes. So remaining constant is the correct answer to that. And we move to the next one. About the next one, this is also a question that I think kerosene oil rises up in a weak of matter, that is surface tension. Intermolecular forces that act between layers of molecule that make them what act like a stretch elastic movement. So keep that in mind. It is just cohesive force, cohesive intermolecular force acting between molecules of what? Of liquids, of fluids, as we call it. So now we have kerosene oil rises up in a weak of the matter because of what, like I said, nothing to talk about surface tension. There's something like that regional pool to understand that rises up. And we are not talking about a narrow tube. The rise and fall of liquid in narrow tube is called capillary action. So keep that at the back of your mind. And we talk about surface tension, water, whether mercury, and water. We talk about wetting of glass, talking about concave and convex discourse, which is also part of what theoretical question for why students can call and cross. Sorry guys, I have to rush this. I promised to use just 20 minutes for this first part of thermal property of matter. The second part, we are going to talk more about the calculation aspect. We will also focus in details about some other questions that are what more technical than this. So the next one is question 9 and question 10, I presume. Now, about question 9, you can see, still on top property of matter, I think now we are on density and relative density. So, from what I can see, very good. The mass of specific gravity, please let it be known, the specific gravity is also called relative density. So, from concept video, you can watch fluids at rest equals to density times 1, or density times 1000, because your density is what is always. And note that specific gravity is a dimensionless quantity. Relative density is not a quantity. And mostly another evidence which are old version of question. Excuse me, the relative density of the substance is measured using the hydrogen. And the relative humidity is measured using the hygrometer. And that one is old version which you can see anytime as well. Be careful about that as well. So now, according to Archimedes' law, we're talking about buoyant force. That is what you call the force that acts on the surface, the total force that acts on the surface. Now, if you talk about the buoyancy, it's either according to Archimedes and flotation, or it's either the both objects that the stroke actually goes down because weight is acting down. The apparent weight, which you call the tension, is also there. And we also have the weight of the fluid, which we call the upthrust, which is known as buoyant force. Now, directly from the knowledge of our relative density illustration, if you have not studied that, let's just keep this all at the back of our mind. It's very simple. Say the relative density of the liquid now is what normally you say relative density of the substance, weight of substance in air, divided by the weight of the carbon. A couple of these guys I'm rushing because I think you have talked about that in your early classes, and if not, which concept at your leisure. So now as relative density of liquid is given in terms of weight of that substance in air, please write that as W prime minus weight of the liquid that you use divided up by weight of the substance in air minus the weight in water. We can do the illustration, but time will not permit. So for liquid, you can always keep this formula in the back of the mind. So guys, in continuation to this, I'm going to break this down. I'm going to have relative density of substance 15.2. So for simplification, I told you we are advancing. I'm going to leave some percentage to finish equals to 15.1 is empty. It is 24.8 when filled with kerosene. The liquid is kerosene. So weight in air now, I say when filled and we have and 27.2 when filled with water. So we are looking for the weight in there. I take that as S, that is empty. Now we have wow, minus the weight of the liquid. The weight of the liquid, which is kerosene, is 24.8. Like I told you, I don't have calculator to do anything for you. So X minus then the weight of the substance in water is 27.2. So guys, on simplification, finish this and drop the answer in the comment box. 15.2, you are opening a bar, X minus 27.2 is equals to X minus 24.8. Please simplify this, my dear students. And I'm waiting for the answer. We have three options here. I don't know the answer. That is mean for you. I will tell you I don't practice all this stuff whenever it is being combined by the students. So what I do is just making sure that I take you through it. Down you are advancing, you have to do some stuff. You distribute 15 points to expand the language you are told in your junior classes. And about the last question for today, because I promised 20 minutes, I think I've used 17 minutes now. If I'm working with my time well, then here we have if a solid X floats in liquid P, wow, it floats. Activity principle and law of flotation. And the density of relative density is 2. I mentioned that quantity I told you. And in liquid Q, the relative density is 1.5. X floats in P of relative density 2 and in liquid Q, okay? It floats in liquid P and it's also floating in liquid what? Liquid Q. So, but listen, guys, the density of P is 2.0, that of this is 1.5. It can be inferred that what dash the weight of P displaced is greater than yes, this is correct. So because we define relative density of density. Or let me even tell you about what buoyant force which I talked about the other time, which is Hawk thrust. Hawk thrust, which is the weight of the fluid displaced. Hawk thrust is the weight of fluid displaced. It's always been as VOG. Concept video talked about how to what derive this for A-level students or for Gamma UTL students. You can Gamma and YX students, you don't need that. So the Hawk thrust, which is called weight displaced. I'm not going to waste your time using one formula. Is proportional to what? Massive density, 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 density. So without wasting time, so the weight displaced of this one is 2 and the weight displaced of this one is 1.5. Simple concept. Don't disturb yourself. You need to understand concept where. When you understand concept where, you don't have to use what scoring all your formula. So that is that about this, guys. This is where I'm going to stop for this video. I do tell you is if you find anything interesting in what you have watched, you can kindly subscribe to this channel because there are other things you can still learn. We also have other platforms for mathematics and chemistry, like I said, for science students. When I finish the first section of this, I'm just talking about the whole topic before I do the general application, which we take part of together. I am going to focus also on chemistry for like let's say for 20 days or 15 days, just like the way I want to do physics. So guys, stay with us for the best of these physics videos and don't forget to share our content with your friend. See you soon in future video. Thank you and always remember to bless. You have a wonderful day. Bye for now.